here. I have excused 2 people based on being sick, but I haven't excused anybody else. You are not the complete group. I would like to take attendance as soon as possible. Would you mind starting an attendance sheet?
We already have one.
Oh, you already have one. Okay. I understand having to struggle with snow, but you are expected to be here, and I don't want to punish the people who don't make it. I want to reward the people who make it every time. That's the principle behind perfect attendance bonus. All right. Today we are going to cover something new. It is new and it's not new. It's an extension of the ideas in 11.7, which were finding extrema of the functions of the type z equals f of x, y, and classifying those. In 11.8, we provide a very specific method. That's Lagrange multipliers. Of finding extrema. You struggled, well, you didn't struggle, but it wasn't easy to find those absolute extrema at every time. The Lagrange multipliers are going to help you. So practically, what should we assume known? That the function of 2 variables that we deal with is C1. Sometimes I assume it's smooth. What do we need? We need that the derivatives exist and are continuous. I assume differentiability. Okay. And what else do I assume? I assume that you have a constraint that is also smooth. Let's say g of xy equals c. You remember we talked about constraints last time on Tuesday as well. So practically x and y are bound to be together by some sort of agreement, contract, marriage. They depend on one another. They cannot leave this constraint. And last time, I really don't remember what problem I took last time, but we had something like, given the function f of xy that was nice and smooth, find the absolute maximum and the absolute minimum of that function inside the, or on the closed disk. Remember that? We had a closed disk, x squared plus y squared less than or equal to 1. And we said, let's find, somebody gives you this very nice function. We found the critical point inside, and we said that's a relative max or relative mean. Maybe we have more, depending on the function. What was crucial for us to do? To study the extrema that could come from the boundary. And in order for them to come from the boundary, we played this little game. We took the boundary, we said that's the circle x squared plus y squared equals 1. We pulled out the y in terms of x and brought it back in the original expression z equals f of xy. Since y will depend on x as y squared is 1 minus x squared, we plugged in and we got a function of x only. For that function of x only on the boundary, we said we look for those critical points for that function. It was a little bit of time-consuming stuff. Critical points that would give you relative max or min for that function on the boundary. Plus, we said, but that function has endpoints in the domain, because the domain will be for x between -1 and 1, inclusively, -1 and 1. So those -1 and 1s as x endpoints can also generate absolute max and min. So we made a table of all the possible values, including all the critical points and the values at the endpoints. We said, whoever's the tallest guy over here is going to be the maximum. Whoever is the smallest one will be the minimum. And that was what the philosophy was before. Now we have to find a different method, which is providing the same solution, but it's more systematic in approach and is based on a result that was due to Lagrange, one of the, well, the fathers. The fathers were Euler and Leibniz. Lagrange had lots of contributions to physics, mechanics especially, and calculus. So he's also a father. As a father, he came up with this beautiful theorem that says, if you have these conditions satisfied, and if f has an extremum already, we know that has an extremum at some point p0 of x0, y0 along the curve, boundary curve. Let's call this boundary curve as a script C. Do you understand? This is not an L. I don't know how to denote. Script C. Script C. How do you draw script C? Let's draw it like that. I'm not an L. Okay? C from curve. Then there exists, I taught you this sign. There exists a lambda, real number, such that the gradients are parallel. What? The gradient of f at x0, y0 will be parallel of a proportionality factor lambda to the gradient of g, the constraint function. So we have two musketeers here that matter. The gradient of the original function, the one you want to optimize, and the gradient of the constraint function as a function of x and y at the point. And we claim that at that point we have an extremum of some sort, then something magical happens. There is a lambda, there is a proportionality between those two gradients. So you say something magic happens, that the gradients will be in the same direction. And the proportionality factor is this beautiful lambda. If Mr. G, this is a tricky thing, you have to make sure happens. If Mr. G, let's say, at x0, y0 is different from 0. Because if it is equal to 0, well, then it's going to be crazy. We have 0 equals 0 for any lambda multiplication here. So that would complicate things, and you would get something that's false. So how do I view the procedure? How do I get the lambda? Once I grab this lambda, I think I would be done. Because once I grab the lambda, I could figure out who the x0, y0 are from the equation. So I have this feeling I need a procedure, I need an algorithm. Engineers are more algorithmically oriented than us mathematicians, and this is what I appreciate mostly about engineers. They have a very organized, systematic mind. So if I were to write an algorithm, a procedure for the method, I would say, well, assume that f and g are nice to you. Don't say that, don't write that down. Assume that f and g satisfy Lagrange's theorem, satisfy the conditions of Lagrange's theorem. Okay. The notion, by the way, has nothing to do with Calc 3, but the notion of Lagrangian and Hamiltonian are something you are learning in engineering, and the Lagrangian is a product of Mr. Lagrange. So he's done a lot for science in general, not just for calculus, for mathematics, for pure mathematics. Okay. In that case, what do you need to do? Step 1. You need to recover that, so solve for x0, y0, and lambda, the following system. What does it mean the two gradients are parallel to each other? This fellow over here is going to be what vector? F sub x, y, F sub y. This fellow over here will be g sub x, g sub y. For them to be proportional, you should have this, that F sub x equals g sub x times the lambda, right? And F sub y equals g sub y times the lambda for the same lambda, your hero here. So both coordinates have to be multiplied by the same lambda to get you the other partial velocity.
And it has to be evaluated at that point.
Yes. So you're going to solve this system, and you're going to get, I'm sorry, with the constraint and with the absolute constraint that you have, g of xy equals c, because these guys are married. They always are in this relationship. And from all the information of the system, you're going to get well, not one, maybe several values of lambda. You get the values of lambda, x0, y0, that satisfy the system. You have to satisfy all the three constraints, all the three equations. I'm going to put them in bullets, red bullets. You don't have colors, but I do, so. And then at all these points that we found in step 1, step 2, I'm going to erase here. For all the points x0, y0, and lambda 0, you got step 1, you have to evaluate the f function. Evaluate f at those x0, y0, lambda 0 we got, okay, for lambda 0, and get to compare values in a table, just like before. See all points will give you an idea who's going to be the absolute max, absolute mean. And I'm just going to go ahead and solve one typical example for your better understanding. You know, it's not solved in the book by both methods, but I'm thinking, since I'm teaching you how to apply the Lagrange theorem today, and do the step 1, step 2 procedure for Lagrange multipliers, I'm going to solve it with Lagrange multipliers first, and the same problem I'm going to solve it in the spirit that we have employed last time in 11.7. And then I'm going to ask you to vote which method is easier for you. And I'm really curious because, of course, I can predict what theorems I'm going to cover, and I can predict the results I'm going to get in the exercises, but I cannot predict what you perceive to be easier or more difficult, and I'm curious about it. So let's see what you think. Just keep an eye on both of them, compare them, and then tell me what you think was more efficient or easier to follow or understand. Okay. I'll take this one, that's really pretty. example 1. It is practically straight out of the book. It appeared as an obsession in several final exams with little variations. The constraint was a little pretty one. It's a linear constraint that you have on the variables. The G function I was talking about, the marriage constraint, is x plus y, and this is the C, little c we are talking about. So how do I know that there exists an x0, y0 extreme? How do I know there is an x0, y0 extremum? I need to look baffled. How do I look? I don't know. I'm just thinking, maybe I can find it. And once it verifies all the conditions of Lagrange's theorem, then I know I'm in business, and I will compute everything and compare the values and get my max and my mean. So, what do we need to do in step 1? Step 1. Oh my God, you guys remind me because I forgot. I'm just pretending, of course, but I want to see if you were able to remember. The two gradients of f and g respectively have to be proportional. That's kind of the idea. And the proportionality factor is lambda, so I do f sub x equals lambda g sub x, f sub y equals lambda g sub y, assuming that the gradient of g is non-zero at that point where I'm looking, and assuming that g of xy equals, guys, I'm going to write it now, but then I have to say who these guys are, because that's the important thing, and this is where I need your help. So you tell me, who is this fellow, f sub x? Minus 2x equals lambda. Mr. Lambda is important. I'm going to put it in red. I know why I'm putting him in red, because he needs to just jump into my eyes. Maybe I can eliminate the lambda. This is the general philosophy. Maybe to solve the system, I can eliminate the lambda between the equations somehow. How about Mr. G sub x? G sub x is 1, so it's a blessing. I shouldn't write times 1, but I'm silly, and you know me by now, so I'm going to keep going and say minus 2y the same way. Mr. Lambda in red, very happy to be there, and times 1 again. Thank God. And then this easy condition that translates as x plus y equals 1. And now what do? Now we start staring at the system, and we see patterns. And we think, what would be the easiest way to deal with these patterns? We see a pattern like x plus y is known, and if we were to sum up the two equations, like summing up the left-hand side and right-hand sides, x plus y will be included as a something in there, as a unit. So I'm just trying to be creative and say there is no unique way to solve it. You can solve it in many ways, but the easiest way that comes to mind is like add up the left-hand sides and the right-hand sides. How much is that lambda plus lambda? 2 lambda, right? And x plus y is 1 because God provided this to you. You cannot change this. Okay? It's an axiom. So, you replace it here, 1. And you say, okay, I divide by 2, whatever. Lambda has to be minus 1. So if lambda is minus 1, do I have other possibilities? So first thing, when you look at this algorithm, you say, well, I know what I have to do, but are there any other possibilities? And then you say, no, that's the only one. For lambda equals minus 1, fortunately, you get what? X equals 1/2. And let's give it a name, because x variable means an arbitrary x0, it's not. And for the same, you get y0 equals 1/2 in the same way. And then you say, okay, for I know x0, y0 now, that's the only extremum that I'm having to look at for now. What is this 0? So I'm going to go ahead and say the point will be P0, 1/2, 1/2, and then I plug in and I say 1 minus 1/4 minus 1/4 is again 1/2. When you compute problems, when you computationally solve problems, many times you're going to see that you make algebra mistakes. If you think I don't make them, you have proof that I make them myself sometimes. What is the best way to protect yourself? A little bit, when you get numerical answers, a little bit, see if they make sense. Does that make sense? Yes. Is the sum 1? Yes. A little bit of double checking with your constraints, your original data, it looks good. All right. So the question is, right now the question is, are we done? The answer is no, we haven't quite looked at what happens with the constraint G, because see, oh, I forgot to tell you that the book, if you look in the book, that's why you should have the book in electronic format so you can read it in Kindle. Example 1 had the additional requirement that x and y are positive. Is such a requirement natural in applications of calculus? Because this is calculus 3 with applications. Can you give me an example where x and y being positive would be a must?
Were they both distances?
Distances or some physical things that are measurable. Lengths, widths, the girth around an object, some positive numbers that, okay. All right, so we will see an example involving dimensions of a box and volume of a box, where, of course, x, y, z will be the length, the width, and the height of the box. So that will come naturally as x, y, z positive. Next, we are going to do. Now, what's going to happen for this kind of constraint? So I want to see if x and y are positive, but at the same time they are married to be x plus y equals 1, I do not have just all the possibilities. I have to have in mind their picture as a couple. X plus y as a couple must be 1, meaning you get the segment, this segment. Are you guys with me? Why don't I expand to the whole line? I say, well, I want to expand to the whole line, which would be stupid. Why would it be stupid? I would get y equals something negative here, and if I expand in the other direction, x would be negative. So it's not a good thing. So the only thing I have is the segment, which has 2 endpoints. Those 2 endpoints are boo-boos. They can give you, the endpoints can give you extrema as well. We talked about it last time. So every time you do this, you do fine, but you have to compare the results against the extrema. These are artificial cuts. In what sense artificial? In the sense that you don't let the whole thing evolve over the whole real domain. Once you artificially cut something, let me give you another example. Don't put this in the notes because I don't want to confuse you. You have some natural so-called relative max and minima here, right? That's a relative mean, that's a relative max, and so on. If I make an artificial cut anywhere, let's say this is not going to be a minimum anymore, I make an artificial cut here, I make an artificial cut here, these endpoints will generate other possibilities for my absolute max and absolute mean. So those extrema are extremely important. I have one, what is this guys, 1, 0, am I right? And this is 0, 1. So I have to look at the possibility when x1, y1 equals, say it again, 1, 0, and x2, y2 was who? 0, 1. And of course, both of them satisfy that. In this case, f of 1, 0 has to be evaluated as well. That's going to be 1 minus 1 squared minus 0 equals 0. And by the symmetry of this polynomial, you are going to have the same answer, 0, in both cases. You're going to draw the table, and this is the perfect place for the table. Perfect place in the sense that you have x, y, and you have, who are your noticeable guys? 1 half, 1 half. Who said 1, 0? And 0, 1. And who was the z? Z was the 1 half here. And here was 0, and here was 0. And I'm going to start making faces and drawing. Did I get the answer? Did I solve this problem at home? Yes, I did. And I got the same answer. All right. So this is max. This is mean. This is mean. The same. So both of these are what? Absolute minima. And these are the absolute extrema for this problem with constraint. I'm going to go ahead and erase and say, remember in the eyes of your mind how much work it was to do this, and I'm going to apply the other method. So how much space? We needed one board largely written. You were able to follow the steps 1 and 2. Should I erase that?
No.
You are my note taker, of course I will listen to you. And then let's see what method number 2 I had in mind. Is the one from last time. So this is a, what is it? A review of, what was the section last time? 11.7. And I'm going to make a face happy that I can have yet another application for you. When this problem appeared on the final, at least 5 times in the last 10 finals or more, different instructors viewed it differently. Practically, the general instruction given to the students, solve it any way you find it easier for you. Just don't make mistakes. So we did not encourage instructors to say, do this by Lagrange multipliers, or do this by, no. Whatever is easier for the student. So what did we do last time about the constraint? Since x and y are married, y depends on x, so y is 1 minus x. And we say this is my guy that I have to plug into the function, into the original function. And then f will not be a function of 2 independent variables anymore, but it's going to become a function of 1 variable. Thank God it's not hard. It's not hard because in this way you have just to pull out the y, 1 minus x, and square it, and do the algebra. So 1 minus x squared, and I'm going to do this really quickly, minus 1 minus x squared, and plus 2x. And okay, so we say, all right, so 1 and minus 1 go away. And they make our life easier, because I have minus 2x squared plus 2x. Of course, I could do it fast, but the whole idea is not to amaze you with my capability of working fast, but be able to follow. So you have minus what? So tell me, you can pull out a minus 2x, and you get x, and a minus 1. And what is special about that? Well, do I really need to do that? That's the question. Could I have stopped here? Is this the point of factoring out? Not really, because factoring out is not going to help me. What I want is to chase after Mr. F prime of x and solve the critical point equation f prime of x equals 0, right? I need to find that x0 that will satisfy f prime of x equals 0. What do I get? I get minus 4x plus 2 equals 0. And I see, I'm already relieved. The moment I saw that, I felt that I'm doing this the right way, because I had the previous method that led me to a 1/2 that Alex provided for somebody for the first time. So now I feel I'm going to get the same thing. Let's see how much faster or how much slower. Y0 corresponding to it will be a 1/2, because a 1/2 plus a 1/2 is a 1. So what do I do? Just as before, I start my table and I say x and y must be 1/2 and 1/2 to give me that critical point in the middle. And I'm going to get a 1/2 for that. And I don't know yet, I pretend. I don't know yet that's going to be a maximum. What other points will provide the books, the so-called the endpoints? And for those endpoints, I keep in mind that x and y again are positive. I should keep this picture in mind, because if I don't, well, it's not going to be very good. So x is not allowed to move. See, x has limited freedom from the constraint. So he's not allowed to leave this segment. X is going to be between 0 and 1. So for the endpoint x equals 0 will provide me with y equals 1. And I'll put it in the table, and I'll say when x equals 0 and y equals 1. And in that case, I plug back in here and I get 0. And again, for the same type of, the other endpoint, I get 1, 0, and I get 0. And it's the same thing. I got the same thing through another method. This is the max, and these are the mix. And one of my students asked me in my office hour, by the way, if you cannot make it to Tuesdays 3 to 5, you can come today at 2 after we are done. I'm going to be in my office if you have questions. So I have Tuesdays and Thursdays after class, right after class. Now, no matter what, you get the same answer. What if you forget about one of the values? Like the student asked me, what if I got the right maximum and I got the right minimum, and I say those are your extrema, and I don't provide you both points where it happens, only one. I don't know. It's different from a problem to the other. Maybe subtracting some credit, but you get most of the partial credit in that case. There will be many values in which you get the same altitude. This is the altitude. Let's see. Do you have questions about? Okay, now it's my turn to make you vote. And if you cannot vote, you abstain. Which one was easier? The first method, the Lagrange multipliers, or the second one, how shall I call the second one? The direct substitution method and derivation, calc 1 type method. So who is for, okay, when you would, you got this on the midterm side, or final. How many of you would feel the first method would be easier to employ?
Second.
And how many of you think the second method is easier to do? And how many people say that they are equally long or short? Or how many people abstain? How many people?
Depends on the problem.
Yeah, absolutely. But I'm talking about this particular one because I'm curious. I'm going to go on and do another problem, and for that one also I will ask you. But Yeah. So, with other problems, it may be that it's easier to solve the system for the Lagrange multipliers than it is to pull out the y explicitly from the constraint and put it back. What else have I prepared for you? I had cooked up something. I had cooked up some extra credit, but I don't know if you have time, but write it anyway, so please write it down. For 1 point extra credit for the next 7 days, read and summarize both of the following methods: Lagrange multipliers with one parameter lambda, which is exactly the same I taught you, and one that is not required for the examinations, which is Lagrange multipliers with two parameters. And that is a big headache when you do that, because you have two parameters, let's call them lambda and nu, I don't know what to call them. When you have that kind of method, it's longer. So it may take you several pages of computation to get to the lambdas and to the extrema and everything. But I would like you to at least read the theorem and write down a paragraph, a short paragraph about what it is. So both of them are 1 point. Both of them are 1 point extra credit at the end.
Together or each?
Yes, sir.
1 point each or 1 point?
No, one both together. I'm sorry, because there will be other chances to get extra credit, and I'm cooking up something I didn't say on the syllabus, like a brownie or point or cake or something. At the end of the class, I would like you to write me a statement of 2 pages on how you think Calculus 3 relates to your major. And one question from a previous student was, I've changed my major 4 times. Which one shall I pick? I said, whichever you are in right now. How does that relate? How is Calculus 3 relevant to your major? Give me some examples and how you think functions of 2 variables or 3 variables appear in your major.
So do we require the 2-parameter question? Like, will there be any question regarding that?
Nothing. Not in the homework. We don't cover that. We don't do that in the tests. Most instructors don't even mention it, but I said, you are honor students, so I'm gonna let you do a little bit of research. It's about a page and a half of reading. Individual study.
Is that in the book? Or?
It is in the book. So individual study, one page or 1 page and a half, so maybe less. Okay. One harder one that I cooked up, and it's not in the book, but I liked it because it sounds like a real life application. It is a real life application, and I was talking to the mailman, and he was saying, I wonder how, because the poor guy was carrying these priority boxes, and he said, I wonder how they optimize when they say flat rate, how do they come up with those dimensions? And it's an optimization problem, and there are many like that in the real world. But for my case, I would say, let's assume that somebody says the sum of the lengths plus widths plus height is constrained to be some number. X plus y plus z equals the maximum possible, could be 50 inches, but instead of 50 inches, because I don't want to work with that kind of numbers, I'm too lazy, I put x plus y plus z equals 1. That's my constraint, G. And I would like to maximize the volume. Say it again, Magdalena, what is the problem? What's your problem? My problem, real. Example 3. Maximize the volume of a box of height, length, height, and width, X, Y, Z, just to make your life easier, in a way that the girth plus the, well, okay, let me make it the simplest way. The sum of the dimensions equals 1. And where can you find this problem? Well, this problem can be found in several resources. We haven't dealt very much with functions of 3 variables, x, y, z. But the procedure is exactly the same. I stole that from a library online that's called Paul's Online Calculus Notes. And imagine that the same thing I taught you would be applied to functions of 3 variables. Tell me who the volume will be. The volume will be a function of 3 variables. Let's call it f, which is what? Who's telling me what that is? X times y times. And are we happy about it? It's a beautiful function. It's not going to give you too much of a headache. I would like you to cook up step 1 and step 2 for me.
Which method?
By the Lagrange multipliers. I specify. For functions of 3 variables. Maximize and minimize f. Okay, so the gradients are not going to be in R2 anymore. They will be in R3. And so what? It doesn't matter. Step 1. Say it again, Magdalena. What do you mean? I mean that you're going to have something like that. The system for nabla f of x, y, z at the point x0, y0, z0 will be in this time lambda times del nabla g of x at x0, y0, z0, where both nablas are in R3. Right? There will be f sub x, f sub y, f sub z angular brackets. So instead of having just 2 equations in the system, you're going to have 3 equations. That's the only big difference. Big deal. Not a big deal. So you tell me what I'm going to write. So I'm going to write f sub x equals lambda g sub x, f sub y equals lambda g sub y, f sub z equals lambda g sub z. Thank God I don't have more than 3 variables. Now, in practice, how do you think engineers solve this kind of system? Do they do this by hand? No. Life is complicated. When you do Lagrange multipliers on a thermodynamical problem or mechanics problem, physics problem, you have really ugly data. There are programs based on Lagrange multipliers. You can have a Lagrange multiplier of 7 different parameters, including pressure, time, and temperature, and it's really horrible. You don't do that by hand. That's why we have to be thankful to technology and the software, the scientific software methods. You can do that in MATLAB, you can do that in Mathematica. MATLAB is mostly for engineers. There are programs written especially for MATLAB to solve the problem of Lagrange multipliers. Now, this is not complete. We are missing the most important, the marriage thing. The g of x, y, z constrained Now there are 3 in the picture. I don't know what that means. X plus y plus z equals 1. So, if and only if, who's gonna tell me what those will be? Are they gonna be hard? No. It's a real life problem, but it's not a hard problem. F sub x will be yz equals lambda. Who is g sub x? 1. Thank you, God. So it's fine. It's not that. F sub y will be xz equals lambda. F sub z is xy equals lambda. There is a lot of symmetry in that. I have some thinking to do. Well, I'm a scientist. I have to take into account all the possibilities. If I lose one, I'm dead meat because that one may be essential. So if I were a computer, I would branch out all the possibilities in a certain order. But I'm not a computer, but I have to think in the same organized way to exhaust all the possibilities for that. And for that matter, I have to pay attention. I have x plus y plus z equals 1. Okay, I'm gonna give you about time yet. I'll give you 2 minutes to think how to set that, how to solve. How does one solve that? How does one solve it? Think how you would grab. Where would you grab the problem from? But think it for yourself, and then I'm gone for 2 minutes, and then I'm gonna discuss things out loud, and I'll share with you how I did.
It could be 1, 1, and minus 1.
You are like an engineer. You already see. Well, maybe I could have some equality between the coordinates. We have to do it in a mathematical way. Right? So, would it help me if I subtracted the second equation from the first equation? What kind of information would I get?
That can give you a ratio. X minus.
We can divide better.
I can divide. That's another possibility. I can divide and do y over x equals 1, and that would give you x equals y, and then you plug it back, and then you say, wait a minute, if x equals y, then x times x is lambda, so lambda will be x squared. So then we plug it in here, and we go x plus x equals 2x, and then we see what else we can find in terms of information. As you can see, there is no unique way of doing that, but what's unique should be our answer. No matter how I do it, I should overlap with Nitish's method. At some point, I should get the possibility that x and y are the same. If I don't, that means I'm doing something wrong. So the way I approach this problem, okay, one observation. I could subtract the second from the first, or I could subtract the third from the second, or I could subtract the second from the first and analyze all the possibilities. Let's do only one, and then by symmetry, because this is a symmetric problem, by symmetry I'm going to see all the other problems. So how do you think in symmetry? X and Y and Z have, it's a democratic world for them. They have the same roles. So at some point when you got some solutions for x, y, z in a certain way, you may swap them. You may change the roles of x, y, z and get all the solutions. So the way I did it was, I took first x, z minus y, z equals 0. But then, let's interpret what this. And a mathematician will go either by if and only if, or it implies. I don't know if anybody taught you. Depends where you're coming from, because different schools, different states, different countries do this differently. But in professional mathematics, one should go with if and only if, or implication. X minus y, z equals 0. And then what implication do I have? Now I don't have an implication. I have it in the sense that I have either or. So this will go like in computer science, either or. Either I do the branching. X equals y, or z equals 0. And I have to study these cases separately. You see, it's not so obvious. In the case, let me take this one because it's closer, my arm hurts. It doesn't matter in which order I start. For z equals 0, if I plug in z equals 0, what do I get? Lambda equals 0, right? But if lambda equals 0, I get another ramification. So you are going to say, oh, I'm getting a headache. Not yet. So lambda equals 0 will again lead you to two possibilities. Either x equals 0 or y equals 0. Let's take the first one. Like a computer, just like a computer. Computer will say, so I'm here, if z was 0 and x was 0, what will y be? Y will be 1. That is the only case I got. And I make a smile because, why do I make a smile now? Because I got all three of them, and I can start my table. That's a pink table. And here I have x, y, z, significant values. Everything else doesn't matter. And this is z, which was the volume, which was x, y, z. Was it, guys? So I have to compare volumes for the stinking box. Right? Okay. Now, in this case I have 0x, y is 1, z is 0. The volume will be, and do I have a box? No, I don't have a box. I make a face like that. But the value is still there to put. As a mathematician, I have to record everything.
You have to like do this on the exam because
Yes,
like, it doesn't make sense. Like this
No,
will not be a
no,
box.
because I haven't said if the box cannot be used. I didn't say I would use or not. So the volume 0 is a possible value for the function, and that will give us the minimum. So what do I expect you to say in the exam? I have the minimum, absolute minimum. One of the points. I'm going to have more points where I have minimum. Okay, the other case. I don't want to get distracted. Y is 0, so I get x equals 1. Are you guys with me? From here and here and here, I get x equals 1 because the sum of all three of them will be again 1. So I have another pair, 0, 0, 1, 0, 1, 0, 0. And the volume will be the same. And another absolute minimum. Remember that everything is positive, the x, y, z, and the bar. I keep going, and I say, how do I get, I have the feeling I'm going to get 0, 0, 1 at some point, but how am I going to get this thing? I'm going to get to it naturally, so I should never anticipate. The other case will give it to me. Okay, so let's see. When x equals y, I didn't say anything. When x equals y, I have to see what happens, and I got here, again, two cases. Either x equals, either Magdalena, either x equals y equals 0, or x equals y equals non-zero. So I'm a robot, I'm an android. I don't let any logical piece escape me. Everything goes in the right direction. When x equals y equals 0, the only possibility I have is z to be 1, and I make another face. I'm quite happy that I'm at the end, but then I realize that is, of course, not what I hoped for. It's another minimum. So I have minima 0 for the volume attained at all these three possibilities, all the 3 points. And then what? Then finally something more interesting. Finally, x equals y different from 0. What am I going to do with that case? Of course, you can do this in many ways, but if you want to know what I did, just don't laugh too hard. I said, look, I'm changing everything in the original thing. I'll take it aside and I'll plug in and see what the system becomes. So assume x equals y different from 0 and plug it back in the system. In that case, xy equals lambda will become x squared equals lambda, right? Mr. x plus y plus z equals 1 will become x plus z, which is 2x plus z, which is 1. And finally, these two equations, since x equals y, are one and the same. They become 1. xz equals lambda. And I stare at this guy, and somebody tell me, can I solve that? Well, it's a system, not a linear system, but it's a system of 3 variables. 3 equations, I'm sorry, with 3 unknowns, x, z, and lambda. So it should be easy for me to solve it. How did I solve it? It's a little bit funny. I got x equals lambda over z. And then I went, but let me square the whole thing. And I'm going to get, why do I square it? Because I want to compare to what I have here. If I compare, I go if and only if x squared equals lambda squared over z squared. But Mr. x squared is known as being lambda. So I will replace him. X squared is lambda from the first equation. So I get lambda equals lambda squared over z squared. So I got that, what did I get? Nitish tell me, lambda equals
like
z
lambda
squared.
is equal to z squared.
So if and only if lambda equals z squared. But lambda was x squared as well. So lambda was what? Lambda was z squared, and lambda was x squared. And it implies that x equals z. X is equal to z. But it's also equal to y. Alex jumped on it. And why would that be? Because x was y from the assumption. So equal to y. So this is the beautiful thing where all the 3 dimensions are the same. So what do we call that thingy? X equals z equals what?
It's a box.
It's a box of a what?
Square.
It's a
Cube.
cube. Okay. So for the
Square
cube,
box.
we get see, they were stingy about the dimensions we can have. So they said x plus y plus z should be at most 1. But we managed to maximize the volume by the cube. The cube is the only one that maximizes the volume. How do I get it back? So I get it back by saying x plus y plus z equals 1. So the only possibility that comes out from here is that I have 1/3, 1/3, 1/3. And I have to take this significant point. This is the significant point that I was praying for. And the volume will be 21 over 27. And I'm happy. Why am I so happy? Why is this 1 over 27 the best I can get? In this case, yes. So I have the maximum. Now assume that somebody would have... It's a small box. Now I'm switching to something. So assume, I don't know why airlines do that, but they do. They give you, they say the girth plus the height would be this. Girth meaning, the girth would be, so this is the height of your, can I get? Or this one? No, that's yours. It's heavy. You shouldn't make me carry this. Okay, so x plus y is the girth. And some airlines are really weird. I've dealt with at least 12 different airlines. And the low-cost airlines that I've dealt with in Europe, they say maximum 10 kilograms, that's about 20 pounds. And the girth plus the length has to be a certain thing. And others say just the sum of the 3 dimensions should be something like that, whatever they give. So I know you don't think in centimeters usually, but imagine that somebody gives you the sum of the 3 dimensions of your checking bag would be 100. That is horrible. What will be the maximum volume in that case?
They'll all be 33 centimeters.
Huh?
They'll all be 33 and a third centimeters.
You mean?
They'll all be 33 and a third centimeters, X, Y, and Z.
No, the sum, x plus y plus z will be 100,
So
and then
each
you
one
have
will be
33.33, whatever. And then you cube that and you get the volume. Now, would that be practical? Why not?
It's like, it doesn't fit.
It doesn't fit the head bin
Yeah.
and whatever. So we try to, because the head bin is already sort of flattened out, we have the flattened ones, but in any case it's a hassle just having to deal with this kind of constraint. And if when you come back to the United States, you really feel, I don't know if you've had this experience, the problem is not in between continents. You have plenty of you can check in a baggage, but if you don't, which I don't, I'm really weird, I get a big carry-on and I can fit that, and I'm very happy. I have everything I need for 3 weeks to 1 month. But if you deal with low-cost airlines, well, that kind of €70 or something between London and Milan or Paris or London and Athens or something, and you pay that little, they have all sorts of weird constraints like this one, x plus y plus z has to be no more than that, and the weight should be no more than 20 pounds. And I'll see how you deal with that. It's not easy. So yes, we complain about American Airlines all the time, but we, compared to those airlines, we are really spoiled. In the ticket price, they are paying, let's say, $300 from here to Memphis. We have a lot of goodies included that we may not always appreciate. I'm not working for American Airlines. Actually, I prefer Southwest a lot. And by the way, they treat us customers and so on. But I'm saying, think of restrictions when it comes to volume and weight, because they represent something in real life applications. Yes,
I
sir.
have a question about the previous problem. Like, I found the 1/3 just by finding the ratio of the first and the second.
That's
and the
how
second and the
Nitish.
third.
Yeah, that's how
Yeah,
I
then I
did it.
You were napping a little bit, but yeah, but then you woke up and while you were napping, he goes, divide by the first equation by the second one, and you get 1. X over y is 1, and so you get the solution of having all of them equal.
Yeah, because I did that out and I was like, oh, it's y is equal to x, y is equal to z, and then you just
Right.
change all of
So
y.
how do you think I'm gonna proceed about your exams? Do I care? No. As long as you get the right answer, the same answer, I don't care which method you are using. The problem for me comes where you have had the right idea, you messed up in the middle of the algebra, and you gave me the wrong algebraic solution. And that's where I have to ponder how much partial credit I want to give you or not give you, but I'm trying to be fair in those cases to everybody. I wanted to tell you, I don't know if you realize, but I stole from you every Tuesday about 7 minutes from your break. And it should be a little bit cumulative. I'm going to give you back those minutes right now, hoping that those 7 minutes you're going to use them doing something useful for yourself. At the same time, I'm waiting for your questions either now, either here or in my office upstairs. And I know many of you solved a lot of the homework. I'm proud of you. Some of you did not, some of you still struggle. I'm there to help you. Is it too early? I mean, somebody asked me, if I read ahead chapter 12, can I have the homework early? Is it too early? I don't know what to do. I mean, I feel it's too early to give you chapter 12 videos and chapter 12 problems ahead of time. But if you feel it's okay, I can send you the homework next. Yeah? All right, whatever. We will start chapter 12 next week, so I extended the deadline for chapter 11 already, and I can go ahead and start the homework for chapter 12 already. And keep it for a month or so. I feel that as long as you don't procrastinate, it's okay.
I solved that one because I've seen it before.